Okay, testing 1, 2, 3. Testing 1, 2, 3. Okay, last lecture, we stopped at this example. Then we go to example number 5. Okay, let's see if you're able to get the concept, huh? Okay, this is in your tutorial question 23. Okay. Now, if you read the question, what do we have here? The car starts from rest and travel along a straight track such that it accelerates at 10 meter over second square for 10 seconds. By reading this one, you already know this one is fall under chapter 1. Why chapter 1? In the straight track. It's in a straight line, right? So it starts from rest, so you know your initial velocity, VO. And it accelerates at A equal to 10 meter per second. Then it decelerates at 2 meter per second. So again, acceleration positive value means it accelerates, become faster and faster. If you become slower and slower, remember the negative sign. Make sense? All right, now draw the VT-ST graph and determine the time needed to stop the car. How far has the car traveled? Try to solve this one. I give you 1 minute. Try to solve this one. What do you do first? You need to draw VT-AT graph. You can, normally question in test 1 will ask you to draw 3 graphs. Sorry. ST, VT, AT. You need to determine the time it needed to stop the car. How far has the car traveled? What the question asks you? T stop, you need to find. Distance or position, you need to find. Change of position, you need to find, means the total distance you travel. What information you have on the T? Zero. Time. What value you have here? Huh? The 0. Read again this statement. Anything linked with time? Nico, answer this question. I'm asking about you about time. What information about time you have? So on your graph, you draw a straight line, right 10. Those watching online, I'm writing something on the whiteboard. Then what else? He deaccelerate to 2 meter. He asks you until he need to stop. So you just create something, because when you study engineering dynamics, it's no longer a constant value. So you need to create some parameter. So on this graph, another one is T stop, correct? Makes sense. So on your graph, now you have 3 graphs on your answer sheet. You have ST, VT, AT. And you have a time information 10 second. Oh, sorry. Unit second, unit second, unit second, unit. Write unit on your chart. And you have 10 second and T stop for the 3 graph. Agree? Right. Now what information we have? What else? Start from rest. What does the information fall into? Is it position, velocity, or acceleration? Velocity. So it start from rest. You know VO equal 0. You need to find until it stop the car. So what is the final velocity? Nico? Final velocity, what is it? Nico? Huh? What does this statement means to you? Needed to stop the car. 0, huh? You have 2 points on the graph here. One is here, one is here. Okay, then read again. Accelerate and deaccelerate. You go to acceleration graph. Accelerate, you have accelerate 1, you have 10 meter per second. Second, acceleration, deaccelerate. What is that correct? If I write 2 meter per second, it should be negative. Huh? So what does it mean? You go to AT graph, then it accelerates for 10 seconds, right? Go to the graph, mark 10 to 10, right? Draw a straight line. Make sense? Make sense to you? Correct, Nico? Like this. Okay. Nico asking why cannot, why don't we draw a slanted line with y equal to mx plus c? We refer to a. Let's say I change our y-axis to a, x-axis to t. You transform linear equation to the scenario. Y is a, m you copy gradient, x is t plus c. What does it mean? A equal to mt plus c. What happened to your acceleration from 0 to 10? If you substitute value here. T equals 0, what is your acceleration? Do you get? What do you get? A equals c. t equal to 10 seconds, what do you get? Do you know how to do linear equation? How you get 10? Nah, does the acceleration, what does it mean? 0? 10? What happened to 5 seconds? Yeah, let's say I change our c is 0 lah. Let's say c equals 0. Okay, c equals 0, I move my graph up a little bit. This is 0. 0, 10, 5. This one is 10 meter per second square, right? What happened when you have in 5 seconds? What's your acceleration have? A equal? What is the equation for acceleration? M5. What mean by M5 or 5M? Let's say your M equal 1. What is the acceleration at 5 seconds? 5 meter per second square. Try to answer, where can you find 5 meter per second square in the statement here? What does it mean? It accelerate at 10 meter per second for 10 seconds. What does this statement means to you? What happened between 0 and 10 seconds? What happened to the acceleration? What does it mean? Is it constant or increasing? This statement, accelerate at 10 meter per second square for 10 seconds. Constant. Then answer your question, why we cannot use y equal to ms plus c equation? Why we cannot use a slanted one? Is increasing. But this statement, it tell you what? It's accelerated at 10 seconds. Means constant. Okay. What does it mean when you have constant? What happened to your gradient? Y equal to ms plus c. What happened to your m when it's straight line? M equals 0. That's why you get a straight line here. Okay. Then what else information you have? Deaccelerate rate after 10 seconds, then it deaccelerate at 2 meter per second square. Decelerate at 2 meter per second square. So on this graph, you need to extend the graph. Mark -2, extend, and highlight this one until t stop. Makes sense. Your air graph, AT graph completed. Now you convert AT graph to VT. Okay. I will explain. So this one on the screen here, I already explained how to generate this graph. AT versus T graph. So A equal to 10 meter per second square, you draw a straight line. All right. So on the whiteboard just now, those watching online, we already explained why we are using straight line and not line with a gradient, right? And -2 here. Okay. Now we want to convert to VT. So draw VT graph. And you know that when you reverse from acceleration to velocity, what equation you use? Integration. What I mean by integration? Area under graph. Right? Correct? You learn integration means dy dx. You learn area under graph equal y dy dx, right? You still remember? So you want to find Vs, you find area under the graph. This is the area here. So area here, can you find area? This is a rectangular on the AT graph. 10 and 10 plus, this is a negative component. So you need to transform the information into here. So you draw the two time frame here. What is the velocity at 10 seconds here? What is the velocity? What's it? What is the area under the graph for this section? Huh? 100 what unit? Meter per second. And if you take this unit, meter per second square, multiply by second, you will cancel out 1 second. So you get meter per second. So you will transform into velocity. So on the graph, from 0 to 10, at 10 seconds, your velocity is 100. This one you do lah, huh? So you integrate. So you use when you transform AT graph to velocity VT, you use definition of acceleration. You write into the integration. This is important. Huh? You need to show this working in your solution when it comes to test or final exam. So this one on the left hand side, it means AT. You take the area under the graph, A multiplied by T, A multiplied by T. Then this side is your velocity from lower limit to upper limit. So you know that it starts from you accelerate means you increasing and increasing, and the question also tell you start from rest. So you know that there's a point here, 100, right? You know there's a point here, 100. Any question on the 100? No, huh? Okay. 0 to 10, you draw a line like that. Because it's accelerate, then it becomes faster and faster. Then this time we use the slanted graph. Okay, I highlight that. So there's a two region, 0 to 10, 10 to T stop. So area under the graph, you find from integration. So you write integration on the left-hand side. You need to show integration. Don't straight away use simple mathematics and you take this one, multiply by this one. You won't get marks for your steps. You need to write integration in your answer. All right. So I'll show you the steps in the green color. Any question on the green color? Just need to pay attention to the limit that you use. For 0 to 10 is 0 to 10 on the integration limit. Same here and here. However, on the left-hand side is velocity, is no longer time. So time is 0 to 10. However, when you come to velocity, it's from 0 to velocity at 10 seconds. V sub t equal 10. Okay. Then here, 10 to t stop also from time from 10 to t stop, 10 to t stop. At. Then the velocity from velocity at 10 seconds until t stop. Okay, then you find the velocity, the area under graph. You get you do integration, you get this form. Make sense? A integrate dt, you get at. Make sense? Then there's a limit 0 to 10. Then on the right hand side, you get v, integrate v to 0. Product integration, this one is at. T substitute 10 minus 0, 10t. This side v minus 0, you get v. What is this form? Linear form. So v equal to 10t. Y equal to ms plus c. This is your m, your gradient. When you get y equal to ms plus c, you can plot the graph. So here you know there's a positive gradient, means it's going up. Plus c is 0. You don't see c here, means it's intersect with 0. This is how you plot. This is how you use your integration. Okay. So we already explained at 10 seconds is 100. So go to the graph. It's 100 here. So we draw a line like this. What happened to 10 to t stop? Okay, sorry. It should be at, not 10t. I write 10, right? Do you spot the Nico? Do you spot the error? Why 10t is wrong? Why this step to this step is wrong? What is the correct answer for integration? It should be, it's not t anymore. It should be a substitute 10. Sorry, you substitute the t with 10. So it should be at. So this is the, I think the first slide I purposely do it wrong. Correction. It should be 10a, not 10t. Okay, correction also, here also. Okay. So here also correction. Right, t 10 second, our acceleration also is 10 meter per second square. Okay, so this is a correction from our mistakes. Next, we need to find another reason. 10 to t stop is this region. We have a negative sign there. So again, we use the integration sign. Left hand side, 10 to t stop a dt equal to integration v time at 10 seconds to v stop dv. Here, when you come to here, you integrate a dt, what do you get, Nico? No. What is the product of this integration? I'm asking you about your integration steps. Nothing linked with engine dynamics. Yeah, in my class, don't blank. You blank, you are waiting for your answer. What is the next step over left hand side? What do you get? You integrate at, what do you get? At 10 t stop. Left hand side, V 10 V T stop. Then you substitute, you run the integration steps. You'll get A bracket T stop minus 10, V T stop minus 100. You already know velocity at 10 seconds. So it is 100 meter per second. Okay, so you have the equation here, right? So it means acceleration is there. Then you rearrange this one. Okay, so you have 10 to T stop. You substitute the value. You know the acceleration on this region. Acceleration is -2. Substitute -2 here. You get another linear equation. Okay, you rearrange, you get linear equation. V equal to -2 T stop 120. So this is V versus T graph. This is V versus T graph. This is Y, this is X. This is a linear equation. What happens when you have a gradient of negative? Positive go up like that, negative go down like that. So this one is like that. You already know the T stop velocity, right? So go down like that. This one, you write equation V equal -2A plus 120. Okay. Any question? Why this one go down? No, huh? Okay. Now we need to find the time when it comes to T stop. You know the velocity. You have one equation here. You have this unknown. What's the velocity when you stop? 0. You only have one unknown in the equation. Rearrange the equation, solve for T. So by looking at on the slide here, what is the T stop? Not minus, huh? It's 60. Okay, you rearrange. Answer is 60 seconds over here. Once you get 60 seconds, you replace the T stop equal 60 seconds. 60 seconds. 60 seconds. Always update your graph. Okay. Basically, you're already done for your VT. AT already done. You want to find your S graph. So you pull your graph. Want to use VT to ST. What equation you use? Displacement, a velocity equation. V equal to dsdt, right? So you use this one, use the same, draw ST graph, put in the time frame, and write the equation, show the integration steps. Okay, so integration step, left-hand side, integrate V dV, means this side is this graph. You see integration means area under the graph. Remember integration, you have limit, lower limit, upper limit, lower limit, upper limit. You solve for one side first. Then you solve for one side. Then another side. This one is from 10 to 60. Substitute 10 to 60 here. Then you get your S at another side. Okay. So same, repeat the same process. You break your procedure into two time frame. 0 to 10, 10 to 60. No longer see T stop here already because you already solved for T stop already. Okay, update your graph with axis. So you know that from here to here, the equation is v equal to 10t. Then this one is minus 2t plus 120. So you solve for this one. So when you integrate, you can find area on the graph, right? This is rectangular, right? Take this one, multiply this one, divide by 2. You get a point on 10 seconds. Okay, so same, integrate 0 to t in 0 to 10. Okay, or yeah. Okay, so you integrate vt, so vt equal to 10. You know that your v equal to 10t. You integrate, you get vt. Sorry, is it correct? Yeah, okay, yeah. Your vt equal to 10t. Integrate, you get 10t squared divided by 2. Okay, then this side is s minus 0. You rearrange, what form you get? What is a form of equation? Quadratic equation. S equal to 5t squared. You have a quadratic equation with positive a, y equal to ax squared plus bx plus c. You have two types of graph. When you a is more than 0, mean positive, you have a smiling face. When you a less than 0, you have a cry face or sad face. Make sense? So what does it mean? This one is a smiling face. So 0 to 10, zip like that. So you draw like that. Of course, negative side we don't see. So it's a half smile. But there's a value on the 10 second, you know, right? What's the 10 second? Area under graph. So 100 multiplied by 10, you get 1000 divided by 2, 500. You have a value of 500 at 10 seconds here. Make sense? Okay. So this graph for chapter 1, all the graph all the curve, all the line you draw on the graph, you must show the equation. Must write equation on the curve. So this one is s equal to 5t squared. You can find the value for this point, right? At 10 seconds. What is the point? What is the value for s at 10 seconds? Substitute t with 10. Then what you get? 500, here 500. Right. Okay, T10 500, so you mark 500 here. Another side, you look at this side. Forget about this equation again. So you substitute minus 2t and so on. So you integrate this one. So you integrate minus 2t, you get minus 2t squared divided by 2. You get minus 1t squared. This one, 120, you integrate, you add a t there. So again, you get this equation. You do the integration step. Still the same. This side, you substitute t there. So t minus substitute, you rearrange. There are two sides. One side is t minus the substitution of 10 inside. One side and one side. It's a long equation. Rearrange. You have a s t term in the equation. You rearrange, you arrive at simple equation. S equal to minus t squared plus 100t minus 600. Again, this is what equation? Quadratic equation. What is the a value? Negative value. So negative is a set face. So draw a set face. However, there is a value there. Okay. So this is a set face. You continue from here. set phase. Then you find the value at 60 seconds. You have this equation, substitute 60 seconds here, you extend this value to the y-axis, you get one value. Okay, 3000. Okay, any question?
How to create the equation?
Integrate what?
After integration, there's this equation, right? The low equation.
This one?
No, the top one.
Yeah lah, you integrate this equation. Yeah.
How to get after
Here to here.
after
You don't understand how to second step to third step here. You know how to do integration? No. What does it mean? This one? This one is your integration steps. Okay, I integrate a dx. What is the next step? I integrate this one. Okay lah, a minus b lah. Oh, sorry. I put ax plus b. I integrate towards x. What do I get in my next steps? This one become a x squared divided by 2 . Come on, this is your integration scale. When you integrate y dx, sorry, not y dx, you cannot do y dx, x dx. What is the step you have? What is the power of x? 1. X n plus 1 n plus 1. This is your limit, lower limit, upper limit. By using this one, you get ax square, because x is 1, you divide it by 2 plus bx. Then you look at this one, same procedure. I only change the index here. Then you'll get from there to here, and then here to here. Then you just substitute. Let's say this is 1 to 2. We have 2 sets minus this one to here. A, you substitute 2 square 2 plus b 2 minus a 1 square 2 plus b 1. What's that? This is the integration homework. You do the same. You'll get this form. Okay. Okay, next step, I'm going to show you how I give you marks in exam. On the graph, each axis will cost you 1 mark. Axis, cost you 1 mark. With axis, each timeline will give you 1 mark, including the value. The curve, 1 mark. Equation, 1 mark. Axis including the unit, 2 mark lah. Axis you have y and x axis, so 2 marks. For one graph, 2 plus 1 plus 1 plus 1 plus 1. 1, 2, 3, 4, 5, 6. It can be 5 to 6 marks. You have 3 graphs, cost you 18 marks. What is the score for question? 25 marks. The rest, 7 marks, is your calculation and steps. Means if you mess up your calculation, your integration, your graph will show wrong. Meaning you'll lose mark for the curve and the line there. You're going to snowball everything. Yeah. Normally, you sure need 3 graphs. This is A versus T, V versus S, A versus S. Your homework. Or you'll see it in the later chapter. Okay. All right. Let's have a short break. Next, what we do, next we will look into collinear motion after the break. Okay, we stop here. We continue 9 o'clock. 10 minutes break.